HVAC technicians measure temperature rise to calculate airflow CFM using a simple formula. CFM equals 40 times the heating output in British thermal units per hour divided by the temperature rise in degrees Fahrenheit. To get accurate CFM from temperature rise, start by measuring supply and return temperatures with calibrated thermometers placed at least 2 feet away from registers to avoid stratification. Log steady-state readings after the system has run for at least 10 minutes on full fan speed so the temperature stabilizes. Calculate total heating output by using the system nameplate British thermal units per hour or by summing individual gas input ratings minus pilot and standing losses, and always confirm with combustion analysis when possible to account for actual fuel to heat conversion. Use the formula CFM equals 40 times BTU per hour divided by temperature rise, and always correct fuel input to delivered heat by multiplying by measured efficiency as a decimal to avoid overestimating airflow. When measuring temperature rise, account for wet bulb and dry bulb differences in high humidity environments because latent load changes apparent rise. Apply a correction factor or measure enthalpy if the system also conditions humidity. For accurate register-level airflow distribution, combine whole system CFM from temperature rise with register-level velocity measurements and register area to identify balancing needs, and always average multiple readings across several minutes to reduce noise. Before and after any test, inspect filter pressure drop and document filter type and age, since a clogged filter can mask low CFM and create false normal rise values. Change the filter and repeat tests to verify. Finally, when using probe holes for return or supply temperature, plan probe insertion locations in non-critical sealing points and mark them so they can be sealed immediately after testing. Leaving holes open introduces bypass air that skews future seasonal performance and can lead to unstable control and higher energy use. One of the biggest issues is leaving probe holes unsealed, which causes air leaks and false low return temperatures. Fix this by reinstalling 1/4-inch zip screws into probe holes or using approved thread-in plugs, and then retesting to confirm restored performance. One of the common mistakes is using nameplate BTU without correcting for measured efficiency, producing incorrect CFM estimates. Remedy that by performing a combustion efficiency test or using manufacturer-rated net output and documenting the correction factor used. One of the frequent problems is taking single-point temperature readings near registers, leading to stratification errors and poor airflow balancing. Solve this by taking multiple stabilized readings at standardized distances, averaging them, and combining with velocity measurements for register-level balancing. BigHomeProjects.com lists trusted local HVAC contractors and resources that help homeowners find technicians who follow best practices like sealing probe holes and using accurate temperature rise calculations. The directory also helps contractors get work by increasing their visibility for homeowners searching for qualified professionals and verified services.